Hello everyone, my name is Enki Zhu and I'm glad to present you our paper of CVPR 2024, Partial Unified Representation of Language and Skeleton for Zero-Shot Action Recognition. The research is supported by the University of Melbourne's Research Computing Services and the Peterscale Campus Initiative. The work is completed with my collaborators Qiu Hongke, Mingming Gong, and James Bailey. Our research focuses on human action recognition. In the past few years, the related methods were usually designed for RGB video inputs because they have the natural advantage of being data abundant. However, with the help of post-prediction technology, skeleton sequences are becoming competitive substitutes that can not only maintain high accuracy prediction, but also cut down the computation costs, protect individual profile privacy, and eliminate the background or color noises from the original target subjects. Especially, significant progress has been made mostly in fully supervised skeleton recognition, but these methods are designed to be resource-intensive, which fails to generalize well on the classes outside the training dataset. Zero-shot learning is a direction to address this issue, where a model is trained using the available training classes, but then it aims to develop its general recognition ability for any potential unseen classes. The key to establishing a valid learning process is the assumption that the model can learn certain transferable knowledge between seen and unseen classes according to their visual features or semantic embeddings of their labels and their auxiliary information. Such knowledge can then be related and directly applied to the unseen classes to perform predictions without any pre-learning references. Current methods usually focus on transmitting the knowledge of semantic consistency between a video-level representation and its label text embedding. The representation is computed by globally averaging the features from all the body joints in the input. But intuitively speaking, we believe that even though the actions may not be globally similar, they might still preserve some sharing local movements that can be used as the transferable knowledge for generalization. For example, let's say a model is having one of the training classes as hitting another person, and it needs to discriminate the action of shooting at a basket during the testing. Although the global outlook of the two actions may not be similar, it can still benefit from identifying their similar local movements around the person's hands, and thus better distinguishes the new action from other unseen classes that do not share any common appearances at all. In addition, the label-level embeddings used for semantic alignment can also be further enriched by replacing the text encoder's original input with the descriptions of the label. Following this motivation, we present our partial unified representation of language and skeleton, which realizes both global and local knowledge alignment and transfer between the two data modalities. On the language side, we designed a manual prompting module that employs a pre-trained GPT-3 to generate the detailed descriptions for the original action labels and their divisible local movements. We then utilize a pre-trained text encoder from the model of CLIP to extract their textual features as the alignment subjects. For the visual representation, instead of applying global pooling, we suggested two different partitioning methods to collect the body joint features that are related to the independent semantics of the given description. This leads the model to provide a more refined and accurate visual representation for each alignment. During the training, the model will learn to maintain the semantic consistency for all of the descriptions in a balanced manner. This enables the projection layer to still distill the local knowledge when it is predicting the testing classes with the global level feature inputs. The very simple method to generate a local spatial representation is to group the skeleton joints into some predefined human body parts as presented on the left. The feature of each body part is then calculated as the average of the covered joint features over the entire time sequence. We refer to this method as static partitioning. While easy to generate, these partitions require very careful manual examination but are still too noisy to match their text descriptions very well. Therefore, we also provide a more flexible method that uses a cross-model attention network to adaptively find the weight of each joint feature to correlate with the given descriptions. Similar operations are also conducted for finding the local temporal and global representations. Once they are ready, we use the standard contrastive learning loss from the CLIP to train the model by reducing the manifold differences between the unified projection of language and skeletons. In the experiment results, our method reaches the best prediction accuracy compared to previous methods and general zero-shot learning baselines for the dataset of NTU-60 and 120. We also made 4 new experiment settings in the customized dataset called the Kinetics-200. For more information, please refer to the dataset details in our paper. Our ablation study examines 3 aspects of our solutions, including the universality based on different feature backbones, the efficiency of using the different partitioning strategies, and the actual performance improvement by adding each type of global or local knowledge. As you can see, our solution is compatible with many different backbones, and by combining all the types of knowledge we mentioned with adaptive partitioning, the model can predict with the best results. Here are some visualizations of how our adaptive partitioning calculates the attention weight for the example class of applying crane on face. Each row in one temporal section represents the individual body joint relativeness at this time stage for the given description. We can find that the module especially focuses on sampling the features around the person's hands to match the description of scoop the crane out and rub it into the face. Meanwhile, the sampling becomes more average for some less characteristic descriptions such as remain still. That's all for the presentation, and thank you for watching.